All right. Welcome. Is this thing on? Oh, we got to switch it to the thing. There we go. It's right here. Let me go back. We were looking at our deck and didn't realize that it's 2 o'clock, so our bad.
Yeah, and we hadn't seen the slides yet. This is the first time.
Yeah.
So.
We automate those. Yep. There we go. Cool. So we'll try that again. Welcome. Yay!
That sounds awesome.
Yeah, that's a little bit better. Cool. Well, welcome to the 2 o'clock session here on the first session day of VMworld. As it states here, we're going to be talking about, at least our view is on enforcing a consistent design when it comes to automation, making your cluster actually match the design. So I have to show you this thing. Cool. All right. And then this is the slide that I made because it's got cool stuff. We're going to kind of try to go quick and dirty right into the content. So we'll start off by Mr. Epping. Who are you? What do you do?
Sure. Thanks, Chris. My name is Duncan Epping. I'm a chief technologist working for VMware in the storage and availability business unit, which is kind of weird because I'm talking about automation today, or actually, I'm not going to talk about automation at all. Chris is going to do all of the talking about automation itself, and I'm going to talk about some of the clustering aspects and why certain aspects within a cluster are important to configure in a consistent way. I'm a VCDX. I'm on Twitter as well, Duncan YB, and I wrote a couple of books, and I've got a blog, Yellow Bricks. So if you're interested in learning more about storage and availability in general, make sure to read my blog. A funny story, actually, before we head over to Chris. I was on Facebook today. You know how Facebook actually shows you the pictures, those reminders of what happened last year and the year before? Well, 5 years ago, I actually met a guy at VMworld, which was Chris Wow. And he had his picture taken with me. So I had the picture up on Facebook, and it reminded me today. So how cool is that? 5 years ago, we had a picture taken together at VMworld. Today, we're actually presenting in front of 800 people. So, awesome.
Dreams really do come true.
There you go, Chris Wow.
Cool. And then this is me. So I'm wallnetwork.com, and there's a bunch of stuff up there. Also VCDX, but I'm most proud of the fact that I'm a dungeon master for a group of Pathfinder nerds. So still rocking the pencil and paper. No electronics are allowed. And probably more prevalent to this session, I'm a Microsoft MVP specifically for PowerShell. So that means, it doesn't mean stump the chump, because you will. I don't know everything even close to PowerShell, but I'm very enthusiastic about what can be done with PowerCLI, which is like the most amazing module / snap-in written for PowerShell, and it happens to be from VMware, which I think is really groovy.
Thanks, Alan.
Oh, and there happens to be that guy over there, Mr. Alan Renew. Cool. So real quick, agenda, what we're going to cover today. Pretty straightforward. Duncan's going to lay down some deep knowledge, some old school tracks, so to speak, on cluster design basics, and kind of set the tone as to what we're talking about when we go into the automation piece. Then I'm going to talk about crafting declarative configurations and why that's important, and why that it seems to be picking up a lot more steam these days, which is cool. Infrastructure as code, and then I'm going to introduce you to a project that I've been coordinating with 4 of my peers called vSphere, which is something you can use today. You can take it home and you can start applying it to your environment. So, that sound good? All right, cool. I'll hand it over to you.
It's a pretty responsive audience, to be honest. So I'm going to talk about vSphere clustering design. That's what I'm going to start off with. Hold on. Does anyone recognize this diagram? There's no VCDXs in the room. I know there's a couple in the room, so I'm surprised that none of you are actually raising your hands. Because this is the architecture methodology that the VCDX team actually came up with and uses in the program as well. Now, if you look at this diagram, and you look at the circle at the top, which says vision, then it follows design, plan, transition, and manage. And those are typically the stages for each of the projects that you guys normally go through. At least those are the stages you should go through if you do it in a proper way. Now, the key reason why I think it's important to have this up on here is because it's actually the foundation when it comes to planning and creating around automation as well. The key thing when it comes to architecture, in my opinion, is creating a consistent design for your environment host. One of the things which is most important, and that's the application. Now, I created this diagram probably 6 or 7 years ago when I presented at VMworld first. And when we start to talk to VMware administrators, one of the things that stand out is that people tend to talk about the blue parts in this diagram. So they tend to talk about virtual machines. They tend to talk about networks, storage, all of the stuff that's important to you. But one of the things that they tend to forget is the application itself, which happens to be the most important part for the business. So besides just talking about your components, make sure that what you're building, what you're designing for, actually meets the requirements of that application. And that's where this diagram comes in again. And that's also where the governance part comes in. So when you talk to your customers, make sure that you actually validate some of your assumptions as well, and that they meet some of the requirements that your customers may or may not have. And that could be anything. That could be a virtual machine from a VM perspective. Can I install VMware tools or not? What kind of storage should I be using? Should I have replication enabled? Can I use the VDS for whatever reason, or can't I use it? What kind of load balancing can I use in a particular environment? All those different aspects are important when it comes to designing a vSphere environment. Now, if you look at the different things from a vSphere perspective, I'm pretty sure that all of you guys are familiar with this, so I'm not going to explain what compute is or what DNS is or how storage works or what kind of different storage systems there are. But these are the typical things you need to think about. Now, I'm going to go into each of these different sections more specifically, and then Chris is going to show you what you can do from a PowerCLI perspective, automation perspective, to ensure that you have everything consistently configured end-to-end. Now, before I do, I'm hoping that everyone understands in this room why it's important to consistently configure an environment end-to-end. I can give a couple of examples. I was just sitting down with a customer. They're a fairly big customer. They happen to be a vSAN customer. They have about 32 nodes in their environment. They had some issues with a particular virtual machine from a performance perspective. So they wanted to do some analysis on what was going wrong. Now, the challenge that they had in their particular environment is they were going through the log files, and on each of the hosts, they had a different time set. Now, you can imagine that if you want to look at the log files itself and go through the different traces, and there's different time set on a host, that, 4 o'clock on host A doesn't necessarily equal 4 o'clock on host B in their case. So it became very difficult for them to actually understand what was happening. So in their case, they actually had to reconfigure the environment first before they could do the analysis from a performance perspective, which is kind of a bad situation to be in, because you want to make sure that your customer can go ahead with that particular virtual machine, and you want to solve those problems instantly. Now, I had a whole list of things on that. I'm first going to talk about vSphere clusters itself. I'm not going to do a deep dive on HA because I probably need an hour or 2 or 3 about it. Are there any people not familiar with vSphere HA? I'm pretty sure no one wants to raise his hands in a room of 800 people, right? But, for those who are not too familiar with vSphere HA, vSphere HA is all about restarting virtual machines when a failure has occurred. And those types of failures can be anything. The most common failure, of course, is a host failure. I'm guessing that the majority of you guys have experienced a host failure of some sort at some point in time. HA, when a host fails, will simply restart that virtual machine on any of the other available hosts in that cluster. Now, what a lot of people don't realize is that HA can do a lot more than that. If a VM process fails, so if for whatever reason that process that actually runs the virtual machine itself is failed, then HA can also restart that particular virtual machine. If an operating system, for whatever reason, fails, HA can also restart that virtual machine. But also if you had a particular storage issue, so if you have a PDL, a permanent device loss, or an APD, all parts down situation where the storage has just gone, HA can also restart that virtual machine in that particular situation. So there are many different things that you can do with vSphere HA. And I think it's one of those features that you always need to have enabled. And it's one of those features where it's also important that when you enable it and you start configuring some of the different advanced settings that there are, that you do this in a very consistent manner as well. Now, I've already mentioned that vSphere HA can restart virtual machines, but how does it actually know that it needs to restart virtual machines? Well, it has a couple of mechanisms to understand what has happened within the cluster to a particular host, for instance. First of all, if you look at a cluster itself, if you have, let's say, 12 nodes, then one of those nodes in the cluster itself is the master, and that master node is responsible for restarting virtual machines. So if anything happens in the cluster itself, then that master node will restart virtual machines depending on where resources are available. Now, it uses a heartbeat mechanism to detect if a host has disappeared. So if a host has disappeared, there's a purple screen of death, or it has been rebooted or whatever happens, then a heartbeat will go missing and HA is capable of restarting that virtual machine. It does this both from a networking perspective and from a storage perspective. So it can look at different layers to ensure that it's not unnecessarily restarting virtual machines, for instance. Now, before it can restart virtual machines, you need to ensure that you have resources available. Most of you people understand what HA is. Hopefully, everyone is using admission control when they configure vSphere HA, because admission control is more or less the policy, the guarantee that you can restart virtual machines when a failure has occurred. The key reason for it being why is when you enable admission control, you're actually setting aside compute resources. And those compute resources are what you need to restart a virtual machine. Now, a lot of people ask me, why do I need resources available to restart a virtual machine? Because I don't have any reservations set on my virtual machine itself. So why do I need to guarantee resources? Well, the key reason for that is because if you restore or if you power on a virtual machine itself, it has a really tiny memory overhead. And that memory overhead needs to be reserved by the hypervisor itself. It's typically in the order of 40 or 50 megs, but it needs to be available. If it's not available, then a virtual machine cannot be restarted. And that's where admission control comes into play. So it guarantees that those resources are available. On top of that, if you set a reservation for a particular virtual machine, let's say Oracle, then it also guarantees that those resources are available and you can restart that virtual machine in a safe manner. Now, of course, there are other concepts from a clustering perspective. There's also DRS. Hopefully, most of you are using DRS. And DRS is all about making virtual machines happy. Chris is also one of those guys. He apparently loves the monster VM. And, you like to keep the monster VMs happy, not just the monster virtual machines, but also the smaller virtual machines, right? Whether it's a big virtual machine or a small virtual machine, DRS doesn't really care. It just wants to make sure that the resources that the VM is asking for is actually provided by the hypervisor itself. So that's the key thing that DRS does. A lot of people think that DRS is all about load balancing virtual machines, but it's not. It's about making your virtual machines happy. It's about ensuring that your virtual machine is actually getting the resources that it's entitled to. So the demand that the virtual machine has from a resource perspective is actually provided by DRS itself. And if for whatever reason the host can't provide the resources, then DRS will allow you to move virtual machines around. And you can do that in an automated way if you desire to do so. Now, on top of that, there's a couple of other things that DRS takes care of. One of the other things, for instance, is maintenance mode. Most of you have probably used maintenance mode at some point in time where you need to do, any type of maintenance from a hardware perspective, for instance. But DRS is the enabler for that. So it allows you to enable maintenance mode and then automatically move virtual machines around to where they fit best based on the demand they have from a resource perspective. So even during maintenance mode, it goes back and sees where it actually can place that virtual machine in the best manner. On top of that, there are things like affinity rules. Affinity rules allow you to separate virtual machines from each other or have virtual machines sitting on the same host for whatever reason. There are different types of affinity rules. There is also the VM host affinity rule. So you can specify which group of virtual machines need to run on a specific set of hosts. That could be, for instance, for licensing purposes. Not everyone seems to like that methodology. But, in most cases, most companies will accept that, except for Oracle. But, I think they prefer to be difficult in this case. Now, there's also other reasons to use VM host groups. Is anyone using any form of stretch clustering? So any vPlex customers? Any NetApp Metro clusters? A couple of people. So if you look at those environments, that's typically also where you see the VM host affinity groups being set up because you want to ensure that a particular type of virtual machine runs in one data center and other virtual machine runs in the other data center. So that's a way of segregating those workloads. Last but not least, resource pools. Are people using resource pools? Oh, actually, quite a lot of people.
Wow.
Hopefully you're not using them for folders, right? Because they are not folders. Let me make that clear. If you are using them for folders, I think Frank Denneman has about 60 blog posts on that particular topic. So go to frankdenneman.nl and look for it, because I'm pretty sure that he can school you on why you shouldn't be doing that. And there's a good example on the right side. So resource pools is all about carving up host resources, or cluster resources, I should say, to virtual machines. Now, the difficult part here is that depending on the amount of virtual machines you have in a particular resource pool, right, it could be contending with other virtual machines in another resource pool. Actually, the resource pools are contending with each other. But depending on how many virtual machines you have within that pool, that kind of determines how many resources that individual machine gets within that particular pool. So, it's, from a UI perspective, it's a fairly easy concept, right? Within the web client, you just create a new resource pool, you throw a couple of virtual machines in there. But, underneath, there's a lot of things that happen from a scheduling perspective, from a resource point of view. How do we assign resources two particular virtual machines. Now, if you look at DRS itself, and if you look at these rules, so the one thing that has always scared me is, just imagine you have set up a lot of resource pools. You've set up, a couple of hundred, or, maybe a couple of dozen VM host groups, and you have, 50, 60 different affinity rules. And all of a sudden, your vCenter server is gone. I'm guessing, in this case, I know all of you 800 guys have vCenter server properly backed up, but, there may be one person outside that doesn't. And if you haven't, well, then there's a couple of things that you can do, and Chris is going to show that in the section that's coming up later. Now, from a compute perspective, there's also many different things that you can configure, and a lot of you guys will probably go through this, once every year, or maybe, once every 2 years, and it's one of those things that a lot of people tend to forget. It's one of the issues that we typically see, for instance, with vSAN. If anything is wrong from a vSAN perspective, it's typically the network, and it's not actually specifically the network configuration itself on the switch, but it's usually things like, DNS or a gateway that's incorrectly or inconsistently configured on the cluster itself. And having that consistently configured is crucial when it comes to the availability of your environment. So there are a whole bunch of things you need to take into consideration when doing it. Now, of course, there's also storage. I don't know if anyone knows Chad Sackett. He works for EMC, and they use storage in a funny way. Apparently, they use it to store water and beers, but besides the point. If you look at storage, it's actually a fairly complex and fairly broad ecosystem. Within VMware, I'm responsible for vSAN. I'm not going to talk about vSAN in particular, but if you look at the way that we've solved it, it's I would say a lot less complex than most of the other systems, and probably most of the systems you guys have out there. So there's a couple of vPlex customers out there, a couple of NetApp Metro clusters customers out here, probably a bunch of you guys, doing all sorts of different types of storage, from NFS to iSCSI to Fiber Channel. And, as you know, there are many different things that can happen in those types of environments. And here, it's really important to have it consistently configured end-to-end. There are many different things that can go wrong, and there are many different things that you need to take into consideration. For instance, can I use storage I/O control on my particular type of storage? If you're one of those NetApp Metro cluster customers, or you're one of those EMC vPlex customers, you can't use storage I/O control, which is something that not a lot of people are actually aware of at this point in time. Can I use storage DRS with the storage that I have? Do I do some form of tiering at the back end? So is my storage array actually moving bits and pieces around based on the latency that they predict? Or can I have storage DRS safely move things around? And then there are other different things, that are important. How many LUNs do I have? How many paths do I have to my LUNs? Do I replicate my storage? You name it. There's many different things that are important from a design point of view. Now, last but not least, the network. Personally, I've always been a virtualization administrator, and I've always been a storage guy. So, what do you blame? The network.
It's always the network.
It's always the network, right? So, and that's what you end up doing. But if you look at the majority of cases, to be honest, even in the cases where I was the admin, I was usually to blame for most of the issues that we had because I, didn't configure the port groups correctly on each of the different hosts. And that's why we introduced the distributed vSwitch. If you're not using the distributed vSwitch, I think it's a great way to ensure that you have things consistently configured throughout the environment, because it's a switch that you can actually create on the highest level instead of on just the host level. But, if you're not doing that, there are different ways of going about configuring and installing those different types of things as well. The other thing that I briefly wanted to mention, because that's something that always goes wrong as well, is the MTU setting. I know Chris is an expert on networking itself when it comes to vSphere, and he can acknowledge that probably. But a lot of the issues that I'm seeing out in the field are due to inconsistently configured MTU settings. So they set it on the host, they set it on the top of rack switch, and that's where it ends. Guess what? If you have vSphere HA configured, and it needs to do a ping, and it travels through the top of rack switch to one of the spine switches, for instance, and the MTU is not consistently configured, then you could end up with, some sort of error, which will happen at some point in time. Same thing for vSAN, for instance. Issues will occur when it's not consistently configured, so that's really important. Last but not least, load balancing. There are many different options, and there are many different theories about that. I think Chris can probably spend 60 minutes just talking about the load balancing itself. The key thing here is that when you configure it, make sure you consistently configure it and that it actually aligns with the type of traffic that you're using, right? don't use the same load balancing mechanism for every single type of traffic. The vSAN traffic behavior is different than vMotion, and vMotion is different than regular virtual machine traffic, and your backup traffic will be probably different as well than regular virtual machine traffic or storage traffic. So those are the different things you need to take into consideration. I think I probably spent more than enough time just talking about the configuration aspect, so I'm going to hand it over to Chris, who's going to do a couple of awesome demos. I've already seen them, and hopefully you guys will like them as much as I did. Here you go, Chris.
Right on. Cool. So I think it's important to have set that table because there's a lot of configurations within vSphere. You know, most of the config work that we do tends to focus, I think, on the workloads and the apps, and we do backups of the vCenter server. But we're busy, at least I was always busy configuring everything manually, going to the PIC client, because I don't like the web client.
Come on. Yeah. Really?
But I felt like that was not the best way. And a lot of the config management tools tend to focus on the application and the operating system. But what about vSphere itself? You know, we have host profiles. Not a huge fan of those either. And they don't really address most of the actual... Man, I keep getting the applause for like ripping on VMware. That's not cool. So,
yeah, I'm pretty sure we won't get a repeat.
Yeah, there's no repeats of this one. But it was really this whole pancake versus waffle thing. You know, I was always focused on being imperative and actually configuring things manually, and that just means that you're doing it step by step by step, next, finish. And a lot of the config held within vSphere, I never really had a good way to control it. And I was doing it manually. You think about DRS rules, he mentioned those, MTU sizes, things like that just were never captured and were done manually, and we don't really know why. And there's much better ways you could do that these days. So I want to be more like the waffle. He's declarative. In fact, I want to be more like Uber in running my infrastructure. I just want to literally just say, I need a car, and I'll tell the dude, or I'll plug in the thing and say, I need to go to this place. And I don't care how I find the driver or which driver picks it. Well, sometimes I care which driver it is, but generically I don't care. Right? I just pick a policy or like a config type. I want Uber X or Uber black car or Uber race car, depending on where you're at in the world. And I want to get there. You know, I don't care about the nuts and bolts, right? And so a lot of folks then say, cool, that makes sense, but where's like the value at? You know, what's the actual value of building configurations for vSphere? Because it is so easy to go in and just configure things. And that's how we've done it for a very long time, and it's kind of comfortable. The idea of using configuration and scripts can be foreign. And so I've got a few like talking head pieces here. I mean, the first, avoid building by hand. You know, that's tribal knowledge. That's the ability to make mistakes. The more we abstract ourselves away from direct configuration, the more we can communicate with it, and the more we actually can take the documentation that we normally write saying, I did this by hand, and now I'm documenting that I did it by hand, and instead you're writing a config which becomes documentation and what's actually going on in the system, right? So you get two birds out of one stone. It's also repeatable. The consistency is king. You always want a consistent environment to match what you, as the architect, are driving towards. So in a lot of cases, you're going to architect whatever it is you want. You're going to document all that process, like for the VCDX, it's hundreds of pages of stuff, and you're going to hand that off to the implementation folks, engineers. There's got to be a better way, and there is. There's ways that you can collaborate on this, some more configuration management type style. It's also a force multiplier, because now I, as the architect, can start boiling this stuff into configs and handing it off to the team, and they can look at it. They can see what happened. I'm not just going in there and configuring things by hand. It becomes more of a communication process, more of a process that you collaborate upon. And tribal knowledge is, I mentioned it briefly, it's the worst, right? It's, well, why is this configured this way? Well, Joe configured it that way 8 years ago, and we don't know what happens. You know, did you ever see the turbo and the more magic button graphic? There was this old mainframe that had a turbo button, and then next to it was magic, and then more magic. And it was always set to like magic, and they're all like, what happens if it goes to more magic? And they took apart the thing, and they're like, well, it's just a wire that goes nowhere. And they set it to more magic just for fun, and the whole mainframe crashed. And like, what the hell does this thing do? No one knew. So it's one of those tribal knowledge things, you know, don't try more magic. Like, who actually does that on their mainframe, though? That seems pretty stupid to play with it like that. So infrastructure as code. Let's talk about that within the realm of vSphere. So I want to start with the fact that I understand you all have VMware environments. You're not starting from scratch. So you're going to need to grab some data out of the infrastructure, right? You all have VMware environments, right? That'd be kind of weird if you didn't. So let's abstract the implementation today and build it into configs. Like kind of go in reverse. And I like to call upon my friend Happy Gilmore. You know, are you too good for your home? Come on. So we'll grab that with some demo time here. So buttons everywhere. There we go. Cool. So here's just a couple examples of ways that you can pull out data. I'm just using PowerCLI, what's the latest one, 6.3, R1, something like that. Ooh, I got it right. It's nice when you can ask the guy who does it for a living right over there. So there's a lot of information you can get, right? You don't need all of it. And I would say start at kind of the higher level. I started with cluster config type data. So if I just run hey, give me all the extension data from a cluster. Here it all is. Here's all the information. There may be some information on the name and things like that. PowerCLI is a great tool because it allows you to grab all the data out of the environment using PowerShell, which is, to me, it's a very easy language. And if you want Python or Ruby or something like that, go for it. The world is your oyster. But you can use any of those, right? Another example, one I think is really big, who actually backs up their DRS rules? I never did. There's a couple people, you're smarter than I was, that I was you document it. And so you can actually, with PowerCLI, I can go in and say, give me all the rules that are in there. I made an example one where I'm doing a VM to host affinity rule. I can grab all that with PowerShell, specifically PowerCLI. I can store those as objects, and then I can make sure that those still exist, right? Which is more than just backing up the database and the config of vCenter itself, right? And there's no host profile that contains this data. You have to document it and save it somewhere. So PowerCLI is a great way to do that. Another example is the switches. There's a bunch of commands you can run to actually export switch data, but I can just show you some switch data here. I can actually say, give me all the port group information. Give me the name, give me the VLANs. It's all there. Some of it's kind of hidden. It's not being displayed on the screen, but it's all there. The complete MTU, VLAN, what type of load balancing policy, it's all there, right? Especially if you've already built all that. I assume you have vSwitches of some sort if you're running VMware, because otherwise, what are you doing? And then even resource pools. I can get all the information on the resource pool, how much memory has been configured, how much RAM, the shares, all that kind of jazz. So that's stuff that it's not easy to capture traditionally. There's not really a mechanism built into the environment. And me personally, that's one reason I'm not a huge fan of host profiles, is then I'm storing the configuration state kind of in the same system that is implementing the configuration state. I realize that they're slightly abstracted, but I don't want the truth of the infrastructure to be saved in the infrastructure. That's like when you have your logging server that's monitoring your storage array writing to the storage array. That's not a good idea. Because then when it goes out, you don't have any logs. So things like that. So this is just to give you an idea that the fact that all this data can be captured, you don't have to start from scratch. You can actually pull the data out and then start enforcing it. And then moving forward, the new data, you can use vSphere and other projects like vSphere DSC to make those changes in your vSphere environment outside of just the virtual machines themselves. Let me just go back here real quick and we'll set up the next piece. Okay. So I've got some backup slides that I put in here just in case, something broke, but they're all just there. I'm just skipping by them. The one I didn't demo because I don't have vSAN currently handy, the storage policy-based management for your vSAN environment. The disk groups, how are they configured, things like that. Making sure that all is consistent and you have that information. So does that make sense so far? Just the fact, really, you can get this data, you can save it somewhere, and then we can do something with it in the next section. Cool? All right. So this is where we go to conversational configuration. And I think it's the coolest thing about IT. I was kind of getting a little down on IT for a while. It felt more the same year after year after year. And then I found GitHub, which was, Git and GitHub is super fun, especially as I work out with new projects and new modules and work with my team internally and folks all around the world. The Pester project has folks from the US, from France, from Germany, all sorts of people I've never met that are just totally smarter than I am that are like, hey, we should do things a different way. This is just an example where I'm collaborating with people across the world on code that is used to configure vSphere environments, right? And it ends up looking like this. I can see all the commits. I can see every time something was changed within the script. I can comment on that. I can have a discussion about it. And I'm not just going into a script somewhere within a file server and saying, change some stuff. Right? I'm saying, here's the changes I want to make and put some comments and notes around it. And have people, literally I had one guy that looked at my code. He's like, well, he was being nice about it. He wasn't trying to be a dick. But he just said, why is it like this? Why are you doing like this? And why not this other way? And I had this big bright light bulb went on my head. I'm like, that's a great idea. I never thought about that. He saved me tons of time on code. So that's a great way to collaborate on code. Right? So one thing I want to show you that I'm super stoked about, it's going to be the major part of the demo, is Pester, which is a project that I kind of kicked off, but now there's a lot of people working on it, which is cool. And it's the idea of taking all these objects that we gather with PowerCLI and using another project called Pester. Everyone heard of Pester before? The It's on GitHub. Not too many people. Cool. So the idea is PowerShell is a framework for writing scripts, essentially to call .NET code abstracted for a scripting language with Windows. It's nothing fancy. PowerCLI is a module and some snap-ins that I'm sure is going away soon that enhances the experience within PowerShell. Right? It gives you specific ability to call functions, commandlets within within VMware via PowerShell. And VMware has always been the #1 vendor in my mind for supporting PowerShell. They've been in very, very early, right? So the idea is if we can take all this data, we can pass it to a testing framework, which is what Pester is. It's actually a unit testing and functional testing framework, and say, go through the config that I want and make sure that it's reality. And we actually take that a further step and say, and if it's not reality, make it reality, or give me the option to make that reality, which is called remediation. Right? So that's where validate always, remediate optional, and then report on that. How many times did I see an issue? How many times did I fix an issue? How many times am I running? And it looks, I hit the wrong arrow there. It looks kind of like this. It's just this script thing. So don't worry, keep calm. It's demo time. So it's not Miller time yet. That's 5 o'clock. There we go. Cool. So first off, where can I get it? I'm sure that's the question everybody has. You can get it on GitHub. Go to Wall Network. Go to vSphere, or look at my blog or whatever. And the first thing I want to do is give a shout out to these 3 other people, Carlos and Brian and Equilin, are guys that are constant contributors to the project. So I think some of them are actually here, which is very cool. So bow to them. Thanks for collaborating. The idea is you go here. There's a long set of instructions that I'm not going to go over because you can read those anytime you want. But you just download the code. Right? You just put it on your laptop or whatever it is. There's no install. You don't have to know anything about frameworks or anything like that. And you go through this config file. And I tried to write it kind of plain English. Is that big enough for people in the back? Is it a little bit bigger? Okay. Okay, thumbs up. Cool. So the idea is, let's take everything we want for vSphere and put it into a config file. I'm really drinking the Kool-Aid on PowerShell, so my config file is written in PowerShell. But I have another friend that's actually rewriting that for YAML in case people want to do YAML instead. And JSON would be fine. Doesn't really matter. But the idea is, for this config file, what do we want to do for the environment? So what's the scope of what we want to affect? In this case, I just start everything saying everything. So just apply it globally. What are my vCenter settings? My IP, there it is. What do I want DRS to look like? And I actually put in a bunch of help here. Do we want it to be fully automated, manual? You just pick what you want, plop it in there. Or you've done like a Git cluster and asked your current environment, what is your current setting? Right? So you can plug all this data in here. If you've used vCheck, I think it's very similar in the mindset of just saying, what are all my config information? That's the beauty of the PowerShell community. We all kind of like steal each other's ideas and try to make the community and world a better place. So homage to Mr. Allen there. So NTP host settings, DNS, it's all in there. I'm not going to go through all of it. And then we say, okay, this is the config. But that wouldn't be good enough. If I just put this stuff in here, how do I know it's legit, right? How do I know I didn't fat finger and misspell something? Well, we should test, right? And we have Pester, which is a testing framework. So let's just test the framework. We can actually say, okay, I'll invoke Pester. That's the command to run the Pester tests. And I can literally just say, test the configs. And what Pester is actually doing is running a test on itself, running a test on vSphere. All these little things that look kind of like Ansible there are actually going through the config file and making sure everything is good to go. That you didn't enter some wild variable that's not accepted. You didn't put a string when it should be an int, that kind of thing. And it's actually connecting to vCenter, making sure the credentials work, all that jazz. So the first thing we do is we test the configuration itself to make sure it's valid. That's important because the one thing I've learned from writing PowerShell for like the last 8 years is that the inputs people give you are like always bad. Or at least you should always assume they're going to be bad. I had one guy, I wrote a script that would customize virtual machines a couple jobs ago. And he put a bug in for me, and he's like, yeah, it's not working. And I said, well, cool, what'd you put in for the customization specification? He said, banana. And I said, why? He said, I want to see what would happen. It's like, you suck. So now I write everything assuming, it's like, I make that joke a lot, but it happened to me. It kind of scarred me for life. But I can't eat bananas anymore, and I always validate that kind of crap can't happen. But that's important. So we're using the same testing framework that is going to actually look at the cluster config to make sure the config itself is good. On board so far? And we can look at that code, example, what the tests are actually doing. This is a Pester test, which is essentially a fancy-looking function in PowerShell. There's nothing all that crazy about it. And the cool thing about Pester is you can describe tests in serial that get run by Pester itself. So it's saying, okay, the first thing we're doing is making sure that the file exists. Duh. We can't do anything if the file's not there. And then we actually load the config file. We load all those variables in. And then we actually make sure that the variables are not empty, that they're all actually there. And then we look at vCenter, and we're going, okay, let's make sure that all the keys are there that we're expecting, that there's a value for it, that it's an IP address. We're doing the same thing for the scope, cluster. We're just making sure that everything's within tolerance. All right, I won't harp on that anymore. The next thing we do now is now that we have a good configuration, is we start looking at the vSphere environment, right? And there's a lot of things we can look at. I pulled out a couple sample tests. In fact, I got some cheat sheet little things I can run here. So I'll just do that because I don't want to fat finger something. So the first thing I can do, don't worry, the red stuff's supposed to be there. It's supposed to be there. Is I can say, cool, Pester, I want you to run the vSphere code and run every test that's tagged with the word cluster, because we can tag all the tests so that we can run specific ones. We can run it by name or tag, or you can tag them banana if you want. I won't care. I won't accept your PR if you submit that to me. And this is saying, well, we checked the DRS mode of your cluster, and we expected fully automated, but somebody's changed it to partially automated. And that's why it's expected, but was, there we go. And that's why that test failed. And we can actually pump that out to NUnit XML. We can have that pass through as variables. We can have that report post to Slack with emojis of tacos, whatever it is that you want, right? It can go anywhere. In this case, we're just running it kind of ad hoc to see what's going to happen, right? And it said the automation level is fine, right? So the automation level itself is good, but the mode is wrong. So it's cool. We know about that. We can now decide, do we want to fix that or not, right? So we can go in. Again, I'm lazy. Sorry about the tabbing. I know I had one guy say that made him a little nauseous, so I can't alt tab any faster or slower than I do. So I can run something a little bit more ugly, because Pester uses a hash tables and we're going to fix that. We have a pull request in that's actually going to give you an invoke vSphere commandlet, so you're not having to do this. I just didn't have time to test it. So what we're saying here is, we'll run that same thing again. I want to run all the cluster tests, but specifically, I want to send a value into the tests of a parameter named remediate and set it to false. So right now, if I run this, the same thing's going to happen, because I said don't fix anything. It's just going to run it and say, cool, I'm not going to fix anything. If I want to fix stuff too, maybe I said, okay, I know this is good, I want to fix it. I can then run the command again and set the remediate to true. And what it's going to do is say, well, I expected fully automated, I found partially, I fixed it for you. And the test now passes. And if we were to run the test again, oops, let me do the tag. It comes back and said everything's good, right? So this is something that in my environment, I'm responsible for running a number of labs for Rubrik, and I don't have people for that. So I wrote this kind of because I am lazy. That's why I've written PowerShell for so long. To just say, just keep fixing stuff, because there's like 50 sales engineers across the world using it, and they like to just break things. And that's okay, it's a lab, I don't care. And this just automatically goes back. It's like having your mom, pick up your room when you're a kid. It's like Pester is like the, I don't know. There's yeah. Anyways, and so that's what it does. I just have a scheduled task that runs this every hour, and there's a ton of tests. You could just run it you can just run it ad hoc and say, yeah, cool, run everything, and it's going to go through all the tests. It's going to validate itself first. Then it's going to go through and make sure there's no snapshots and things like that. I mean, it just goes on and on and on. And if there's any issues when you run it without any commandlets, it's just going to tell you, hey, there was an issue, and then report at the end that there were issues. So right now it's looking for snapshots on all my virtual machines for 9999 days, because it's just kind of a fake thing. Checking for CPU limits on the virtual machines. We can test for all sorts of crazy stuff. I'm not going to let that just run forever. So how does that work, right? So far, do you kind of like the idea? Is that cool? One guy said it was what host profiles should have been. So I was like, I didn't say that. He said that. So I'm just repeating it. So how does this actually work? It's actually really simple, and it's really easy to contribute to. And we are kind of reinventing the wheel, but I noticed that there's a lot of frameworks out there. Like I actually love Ansible a lot. And Red Hat owns them now, and I'll let you interpret that however you will. And Chef. I've not really latched onto the Puppet wagon, but I've always liked Chef and Ansible. And so this felt kind of Ansible-like to me. But none of those frameworks really are designed to do stuff to vSphere yet. There's some projects out there. They're kind of half-baked. I think vSphere DSC is one of the best ones out there. But that's why I said I'm going to just do this instead. So how does that work? Let's look at the DRS tests. So again, it's a function, and we're defining 2 parameters in the beginning, right? And they're very straightforward, and we try to comment on everything. Essentially remediate, and by default we set that to false because we want you to specifically tell us that you want to fix stuff. Because the worst thing that can happen is you set some weird config value and it just goes nuts. And then where's the config file? And the reason I asked for a config file is because not everybody has one vCenter with one cluster like I do. Some people are going to have 10 vCenters with 59 clusters, and you might want to config for each one, maybe prod, dev, something like that. So you can set all sorts of clusters, and this is just the default one. So the way it works, I'll scroll down just a little bit, and hopefully everybody can read. I know it goes off the screen just a little bit, but first thing we do is we describe the name of the test, and we tag it. So in this case, the name is cluster configuration, DRS settings. I have a format that everyone has to follow that contributes, and I've tagged it with vCenter and cluster, and you can add more tags or put in pull request saying it should have this other tag. We then pull in all the information from the config. So this is saying go into the config and grab the requested DRS mode and DRS level. DRS level is the 1 to 5, how aggressive do you want to be, and the DRS mode is the essentially fully automated, that kind of stuff. And then we go through all the clusters that you set in the scope and say, let's go ahead and look at the cluster config. Let's check the value of the current DRS automation level for this test. And the value should be, that's Pester lingo, should be what I've defined in the config file. And I use what's called a try and a catch. It's a very common thing in programming to say, if there's an error, if it's not true, basically, if there's some kind of exemption, do some other code. And that's why it tries that. If they are not true, if they don't match, it then catches it and says, well, if they turn remediation on, fix it. And that's why this little piece is here. I'll scroll over a little bit. That's what this block of code is saying. If someone specifically said true to remediate, go ahead and write a warning. That's why it said we found an issue. That's the dollar underscores, basically the current message. And then we're going to remediate it. And then it actually does the remediation. And a very specific thing here is error action stop. So for some reason, we aren't able to fix it. You gave me bad credentials, or it's some kind of value that we didn't think about, that you put banana squared in there. We weren't thinking about banana squared. And that's not the vSphere API says, yeah, you can't do that. It would error out and the test would still fail. So it would try and fail. That's very important. And that's pretty much all the code is doing. It looks really fancy, but that's it. And if it's not able to do it, throw the error. That's all it's saying. And then it goes through different tests. And with this, you're able to pretty cleanly and rapidly go through the entire environment. It looks for NFS, BDS, all that kind of jazz. I'll show you the BDS one as an example. This one runs really quick. Let me pull it up here. And if there's any questions, please let me know. I know I'm going kind of fast. No, just tag BDS. So invoke Pester, tag BDS. So there we go. We looked at all our switches in 500 milliseconds plus or minus. For link protocol, make sure you're using CDP, LLDP, advertising both ways, MTU. And I've been adding new features. The next pull request is going to look at the actual port group config. So you can say these are the port groups, and this is what they should be configured as, and all that kind of jazz is there. Cool so far? Is this cool? Is this exciting? Is this something you're going to use and download? All right, I can't. It's so quiet. So I'll pull up a list here. I mean, I can demo more stuff. We can do more questions. I can just have this running. Sometimes I just it because it's fun. That's the kind of guy I am. So these are some resources. These are the places you can get everything. First off is vSphere. Completely open source under the Apache 2 license, which means do whatever you want with it. If you make a change to it and you don't want to contribute it, totally fine with that. Don't feel like you're a jerk if you take it and you just run with it, because that's going to happen and I don't care. If you have something and you're like, hey, I'd like to contribute it back, I've had a lot of people give me tests that they've written and put them back into the system. So that would be cool too. I want to give a huge nod to vSphere DSC that Luke Deakins has been writing. He's also got that on GitHub under his environment. I think that's another good way to do this. I hope that one becomes really robust. Personally, DSC doesn't make a lot of sense to me. I'm still not able to connect the dots on it. So that's how I wrote this. And then 4 other projects that I really recommend and love and have been trying to contribute to. The OVF, the Operation Validation Framework, not the OVF you're probably used to, is actually a way that you can take configs and turn them into modules. So you can version configurations. It's pretty awesome. And then Watchman, I think it was written by the guys at Columbia, the clothing folks. And it actually looks at those configs and is able to, run Pester against modules of configs and starts becoming Inception. of course, Duncan's HA deep dive. Because my biggest pet peeve was he writes all these cool blog posts about use this, DA dot, these funky looking characters for setting cluster configs that I needed, like turning off the SSH warning and allowing it to not have, only one heartbeat data store, things like that. These really obscure config things, and I'd put them in there, and then I'd forget what they were and how to do them, and things like that. And we can just put those into vSphere, and then you never have to think about that again.
I also documented them for you. So.
Yeah, he did all the work. I'm
just in case so it's clear, so the free ebook is actually posted up on GitHub as well. So I shared it through Gitbook. That means that if you find any mistakes in the book itself, you can actually mention those. So you can leave a comment, you can actually submit changes for it, and I can pull those into the book itself and distribute a new version. So it's available for free. It's based on the latest version of vSphere HA 6.0. So all of the new details about APD, PDL handling, all of that is available for free. So download it if you want to.
That's awesome. Yeah, all right. And then, I can't say enough. That's
Thanks.
Awesome. I think everyone here has written your HA deep dives and DRS deep dives.
Let's hope so.
The orange and the blue books. And then the last one is PoshSpec. If you're new to writing PowerShell, or at least formatting PowerShell, there's kind of this agreed upon, like a gentleman's agreement on how to write code and ways to format it. There's two things you can do. Number one, definitely check out PoshSpec. It's basically just documentation on how to write really good, clean, communicative PowerShell code. But also, you can grab ISC Steroids, which is a module that you can grab using Windows PowerShell 5. You can get it from the PowerShell gallery. And it's going to allow you to refactor your code. So you can actually write kind of semi-messy code. It'll go through and fix it. Like if you use shorthand, aliases instead of the full-length code, it'll fix that for you and change your brackets and indentions and things like that. I couldn't fit that on the slide, but ISC Steroids is another one. And with that, we're done. Hope you enjoyed it. We'll stay around for questions, but thank you so much for coming.